Alright, so now we're looking at some binary operation exam question. So this is a real exam question. So it said that the binary operation star is defined on the set of real numbers. So it says show that the binary operation star is closed under real numbers. So to show that it is closed under real number, what we need to show is that A star B for any real number A and star it, then the result is also going to be a real number. Alright, so that's what we're going to show. So here's where we use some Cartesian product. So look at this now. So this is how we can do the first part. Very easy. So we have that A star B is equal to 7 plus A plus B, right? Where we can tell them A is an element of real numbers and B is an element of real numbers, right? Then now by addition, by commutative law under addition, remember what commutative law states. By commutative law under addition, we learned that A plus B is equal to B plus A, where this result A plus B is closed under addition, where A plus B, the result is going to be a real number. So this part right here, we've just shown using commutative law that this part is an element of real number, right? Now, what you can tell them is now 7 is also an element of real number. 7 is an element of real number. And so 7 plus some real number A plus B is going to therefore be an element of real number. So this proves that we get a real number. And so therefore star is closed. So then now we use therefore star is closed under real numbers. Star is closed under real numbers. So star is closed under R. Star is closed under R. Alright. Now the next part says find the identity element star. So remember, to find the identity element we use one simple equation. To find identity we solve A star E equal A, and then we look for E, and E is the identity. So right here, to find the identity we're going to write A star E equal to A, and the identity that we want is E. So A star E, what is A star E? A star E is going to be 7 plus, you replace A with A, so you get A plus A star E, E with B, so we get 7 plus AE equal to A. Now the A's are going to cancel, this A cancels this A on that side, and so what we're getting then is 7 plus E is equal to 0, and so then what we're getting is that E is -7. And so what we're getting right here is that the identity is E, which is -7. Easy question. So the next part says find the inverse of any element A. So to find the inverse of any element A, remember it specifically says A, then the inverse of A is A to the -1. And we need to carry out that operation such that the result gives us E. So what we're solving then is A star A to the -1, we get 7 plus A plus a to the minus 1, and that result is going to give us e. Now what is e? E is negative 7. Alright, so what we're getting then is we can bring the negative 7 over there, and so what we're getting then is that make a to the minus 1 the subject. We get a to the minus 1 is equal to, bring over 7, we get negative 14, and then bring over the a, we get minus a. And so what we're getting then is that the inverse of a, which is a to the minus 1, the inverse is equal to negative 14 minus a. So this is the inverse, and this is the identity. That's the identity. Alright? So very easy questions. Easy. I know it's saying question 6 because I took it out of a worksheet and I wanted to look at these two specific questions. So now, let's look at question, well it says 7, but for us it's really question 2. So it says, given the binary operation on the real number star, x star y is 5 times x plus y, and x delta y is 3xy. Determine which of these operations is associative, which is commutative, and determine if star is distributive over delta, and determine if delta is distributive over star. So let's label them as, I'm going to start with I, commutativity. Alright, so we need to check which of these operations is commutative. So let's start with x star y is 5 times x plus y. So x star y, so we're solving part I, right? So let me just put this line right here to show the solution right there. So x star y, this is equal to 5 times x plus y. And so 5 times x plus y, but according to operations on a real number, x plus y is the same as y plus x. So I can rewrite this as y plus x. But then 5 times y plus x would be y star x. And so x star y is equal to y star x. And so therefore we can therefore definitely say star is commutative. So star is commutative. I'm going to write COMM, which is shortening for commutative. So COMM is shortening for commutative. So star is commutative. Now let's check if delta is commutative. So we have x delta y, and that's equal to 3xy. But 3xy, we can write 3xy as 3yx. And 3yx, that would then be equal to y delta x. And y delta x is equal to x delta y. And so what we can say then is delta is commutative. Delta is commutative. Commutative. Easy question, soft. So now the next thing we need to look at is associativity. So to determine associativity, what we're going to have to show is we need to just show that x star y star z, the operation, the order of the operation does not matter. So we just need to show that x star y star z is equal to x star y star z, where the order does not matter in which we take the operation. So this is what we need to show. X star y star z is equal to x star y star z. So let's say we'll start with our left hand side. X star y is going to be 5 times x plus y. So it is 5 times x plus y. And then we're going to take the star of z. And so what we need to then look at is what is 5 times x plus y star z. Well, the result is then going to be 5 times the first number plus the second number. So if it's 5 times the first number, which looks like 5x plus 5y, 5 times the first number plus the second number, which is z. Alright? So that's what the left-hand side works out to be. Now what is this simplifying down to be? I have no idea. This looks like, let me simplify it. So what I'm getting that this is simplifying out to be 25x plus 25y plus z. So let's leave it this way then. So then now we need to show that x star, y star, z, it should be equal to what's on the left hand side. Then and only then it would be associative. So let's check it out. So we're going to get x star, y star, z is going to give us 5 times the sum of the two numbers, which is y plus z. Then the result is going to be x star 5 times y plus z. So the final result is going to be 5 times our number x plus 5 times y plus z. Now clearly this is not equal to what's on our left hand side. So what we can then conclude is that this right here, because this right here is giving us 25x, this have 5x, this I give 25y, and this I give 5z over here, so I get 25z. So the left hand side is not equal to the right hand side. And so let's continue over here. So what we can say is star is not associative. Star is not associative. So continue part 2 right here. And so what we say is star is not associative. I put ASS for associative. ASS. Right, ASS, not say the word, just ASS. That's for associative. So star is not associative. So now we need to check if delta is associative. To check if delta is associative, we solve x delta y, delta z. The order does not matter, it should be equal to x delta y, delta z, x delta y, delta z, and the order should not matter. So we can take x delta y first, or we can take y delta z first. Now let's check x delta y first. To get x delta y first, then what we're getting is x delta y is giving us, x delta y is 3xy, and so we get 3xy, delta z, 3xy delta z. Now 3xy delta z, this part is going to work out to be 3 times the product of these two numbers. So it works out to be 3 times the product of 3xyz. And so the final answer works out to be 9xyz. 9xyz. Now what are we going to get over this side now? Let's check it out. So x delta y delta z is going to be x delta, what is y delta z? Y delta z is going to be worked out to be, what is y delta z? Y delta z is 3yz, 3yz. And so what we're getting then is x delta 3yz is going to be 3 times our first number y, x, times 3yz. And so what this works out to be is 3 times 3 is 9. And so we get 9x, y, z. And so that's how we would show that delta is indeed associative. So delta is associative. So remember, it's ASS for associative. So delta is associative. So the next one we want to do, the final part of the question, is determine if star is distributive over delta, and determine if delta is distributive over star. So let's do that on a fresh sheet. Let's do that right here. So again, so just to write it down back, I think it was x star y. X star y, we said that was 5 times x plus y. And then we said that delta, x delta y, we said x delta y was, I think, 3xy. So then to determine if star is distributive over delta, let's start with that one. To determine if star is distributive over delta. To determine if star is distributive over delta. Determine if star is distributive over delta. So let's determine if star is distributive over delta. If star is distributive over delta, then x star y delta z, x star y delta z, that should be working out to be x star y delta x star z. That's if star is distributive over delta. So let's find out if this is true. So on our left hand side, what we will get is x star y delta z. Y delta z would be 3. This part right here would be 3yz. So 3yz. And so we need to work out what is x star 3yz. Now x star 3yz is going to work out to be x star y. X star y is going to work out to be 5 times the sum of x and y. So it is 5 times the sum of x plus 3yz. 5x plus the sum of 3yz. Alright, so that's the left hand side. Now the right hand side is going to be x star y delta x star z. Now what is x star y? X star y is 5 times x plus y. So we get 5 times x plus y. And then we're going to take delta of x star z. Now x star z is going to be 5 times x plus z. So now let's have a look at what this side simplifies to be. So now this is going to simplify to be 3 times the product of the two of them. It's going to be 3 times the product of these two numbers. 5 times x. It's going to be 5 times 3 times the product of 5 times x plus y. 3 times the product of 5 times x plus y. Times, let me just write 25. Because this 5 and 5 give me 25. So we get 25x plus y times x plus z. Now clearly, these two can't be equal. Clearly, this is not equal to this. And why it's not equal to it, that is clear. Because 5 times x will give me 5x. Well over 5x already on the right hand side. And 5 times 3 is 15. So, and some terms missing, so clearly star is non-distributive over delta. And finally, let's determine if delta is distributive over star. So let's determine if delta is distributive over star. So to determine if delta is distributive over star, again we write down what x star y is. X star y is 5 times x plus y. And then we write down what x delta y is. X delta y, as we know it, x delta y is equal to, what is x delta y? X delta y is equal to 3xy. And so now we want to show if delta is distributive over star. Delta DISS for distributive, delta distributive over star. So this is what we're testing for now. If delta is distributive over star, then this is what happens. Then we can say that x delta is distributive over star, so we get x delta y star z, and that's going to be equal to, this part is going to work out to be x delta y star x delta z. That's if delta is distributive over star. So if delta is distributive over star, then this is what happens. This is the magic that happens. So now let's simplify this magic. Alright, let's go, let's do this. So let's start with our left hand side. What is y star z? Y star z is just gonna work out to be 5 times y plus z. So this part works out to be y star z is 5 times y plus z, and then now we need x delta 5 times y plus z, but then it's just x delta y is 3xy, so this part just works out to be 3 times x times our second number y, which is 5 times x plus y plus z rather. And then we can simplify this left hand side to get 5 times 3 is 15. So we get 15x times y plus z. That's what we get on our left hand side. So now let's simplify what we get on our right hand side. So on our right hand side, what we have now, we have x delta y. And so to get x delta y, well, we need to find what is x delta y. So let's find what is x delta y. X delta y is 3xy. This is 3xy. Star x delta z. What is x delta z? X delta z is 3 times xz. So now we need to work out what is 3xy star 3xz. So the result is going to be 5 times the first one plus the second one. The first one 3xy plus the second one 3xz. And so what we're getting now, 5 times 3xy plus 3xz is equal to 5 times 3, that is 15xy plus 15xz. 15xy plus 15xz. And so what we can then do is factorize out 15x. And so what we're going to get is 15x into y plus z. And so clearly our left hand side equal to our right hand side. So when our left hand side is equal to our right hand side, then clearly it is true. And so yes, delta is distributive over star. So we can conclude delta is distributive over star. Delta is distributive over star. So we can conclude that delta is distributive over star. Easy does it, soft. That's it.